Hello everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about routing algorithms. Already in previous session, we discussed about static routing algorithms as well as the dynamic routing algorithms. In static routing algorithms, we already discussed shortest path algorithm, and next we discussed flooding. Next one is flow based. These three algorithms we discussed in static routing algorithm. In dynamic routing algorithm, we discussed distance vector routing algorithm and link state routing algorithms. These two comes under the dynamic routing algorithm. These dynamic algorithms are also called as the adaptive, and static routing algorithms called as the non-adaptive routing algorithms. These all we discussed in previous sessions. Now we are moving to remaining routing algorithms. What are the remaining routing algorithms? Let us see the overview. These are the routing algorithms. Those are the hierarchical routing algorithm, broadcast routing algorithm, and multicast routing algorithm. Today we are going to discussing about all these routing algorithms in today's session. First, let us see hierarchical routing algorithm. What is hierarchical routing algorithm? Hierarchical routing algorithm mainly talking about procedure of arranging the routers in hierarchical manner. We have to arrange all the routers in hierarchical manner is called as hierarchical routing. So mainly this type of routing algorithm mainly used in telephone exchange. In that particular telephone exchange network, we are going to use the hierarchical routing algorithm. How exactly the data is going to be transferred in this telephone exchange? So these are the local loops. These all are the local loops. These all are local loops. These are connected to end offices. These are the end offices. These end offices all are connected to toll offices. These are all are the toll offices. Means this is like a hierarchy. Here it is going to be follow some hierarchy. Like that it is going to be used in hierarchical routing. Means this is the example of this telephone exchange is the example for the hierarchical routing algorithm. Means whatever the local loops, end offices, toll offices, that is the tandem offices, all are arranged in the hierarchical fashion. That's why we are called as a hierarchical fashion. So the routers are divided into regions. In this hierarchical routing algorithm, it is going to be divided into regions. Whatever routers are there, those are going to be divided into regions, with each router knowing all details about how to route the packets. Means router is going to be divided into regions. Whatever routers are there, suppose 1, 2, 3, 4, 5, 6, 7, 8. These are the different routers. Here the connection is there like this. Suppose this is the connection for these particular routers, that is the local loops. We can call it as a local loop. So here each router knowing all the details about how to route all the packets. Each router having that particular information. Means it is going to be called as region 1. It is considered as region 1. It is considered as region 2. These are the two regions. You can assume that it is going to be divided into two regions. So here it is the two regions. Here we are giving the connections to all other routers. Means suppose here the connection in between 2 to 5 is there. Means from 1 to we can travel 8 also if the connection is there in between 2 to 5. That is nothing but each router knowing the details of how to travel to all other packets. All other routers to route the packets with the destination within that particular own region. Suppose if I want to travel from 1 to 4, I can know the route 1 to 2, 2 to 4 also I can travel, 1 to 3, 3 to 4 also I can travel. Means all the details about how to route the packets to destination within its own region. This is the region 1, this is the region 1, region 2. Means within that particular region how to route the packets it will know. So but knowing nothing about the internal structure of the other regions. But it will know this region only. It will only know this particular another region. Means only inside the region it knows everything. Means it can send the packets easily. But outside the packets it can't send the packets easily. That is the condition. Knowing nothing about the internal structure of the other nodes, other regions. That is the region 1, region 2. So how it is going to be happen? See what are the steps are there in hierarchical routing algorithm. So this is the hierarchical routing algorithm example. So here total how many regions are there? Region 1, 2, 3, 4, 5 regions are there. These are the 5 regions are there. Each region having their own again routers are there. In this region 1, how many routers are there? 3 are there. A, B, C routers are there. In this region 2, how many routers are there? Total of 4 routers are there. D, E, F, G are the region 2 routers. And coming to region 4 routers are M, N, O are the region 4 routers. Means each it is going to be divided. Suppose this total is called as a cluster. This is the one cluster. This is the cluster. This cluster is having the number of regions. Each region is having the number of routers. That is the condition. So hierarchical routing, routers are classified into the groups is known as the regions. Whatever routers are going to be there, those are going to be classified into the groups. Here this is one group, this is another group, this is another group. It is going to be divided. These groups are nothing but the regions. Each router has only the information about the routers in its own region. Means A is know about the B and C is know about the A and B, but C is don't know about the K. Means each and every router knows the only information about the routers in its own region and has no information about the routers in the other region. Means suppose if we want to travel B to M, it won't have that particular information. To that only we are going to use this particular algorithm. Routers just save one record in their table for every other region. Router, suppose A router is each and every router maintaining the routing table, right? For that, for routing a table of A, this router table A we are going to write it. So this table is saying what it is going to say. Suppose if A wants to travel from A to M, exactly it store only one record for this particular data. Means how it is going to travel from A to M. If we want to travel A to C, C to P, P to N, N to M, it has to travel. So, but it store the data about the. So suppose A to M, if you want to travel, so A to C already this is only one region. Suppose it will mention the record of the region 5, region 4, but that is also only one record it will place for sending the data packet from A to M. That is nothing but the one record. So routers only contains the record of the immediate neighbors in that particular table. Routers, whatever router is having the routing table information, only immediate neighbors in that particular table. What are the immediate neighbors of A is B and C only. It is having the information about immediate neighbors of that particular region. So, in the 3-level hierarchical routing, the network is classified into number of clusters. In the hierarchical, mainly it is going to talking about what? Cluster. So, total this, whatever diagram is there, right, it is called as one cluster. So, means each cluster is made up of number of regions. So, each cluster is having the number of regions. Here 5 regions are there. Region 1 is there, 2 is there, 3, 4, 5. Cluster is having number of regions. Each region is having the number of routers. So here number of routers are there in each and every region. That is the condition. So in this method it will route the first to the region. First it will reach to the first region. Then it is going to be hide the within the region. It is going to be hide the some details. How it is going to happen? See first here. With the example, we can understand clearly about the hierarchical routing. So, see in this algorithm, see first see here how many regions are there? Total region 1, region 2, region 3, region 4, region 5. 5 regions are there. So, in that each region means this total is called as what? This total is the cluster. Like suppose in we can consider for some college. Suppose this is the college. In this particular college, this is the cluster. Maybe somewhere this college is having number of number of campuses are there. So this particular college. So here it is nothing but cluster. It is having the number of regions. Regions are nothing but in this college number of departments are there. What are the departments here? CSC is there, CSIT is there, EC is there, EEE is there. Here these are all nothing but the regions. So next one, in each and every department where number of faculties are there. Number of faculty. Whatever faculty are there, those are nothing but the routers. You can consider like that. This is the, like suppose this is one department, this is another department, this is another department, this is another department, like that. These are the number of departments. In that particular department, here these are the faculty of CSC, these are the faculty of EC, the EEE, these are the faculty of CSIT, these are the faculty of Aero, and these are the faculty of Mechanical, if you consider like this. But in this CSC, maybe these are the faculty members. They don't know exactly all the faculty of these faculty. So only one faculty knows the other faculty of mechanical. That is the condition. Like that, we have the links for all other faculty. This is the condition. So for that, we have to find the table for A. That is also 1A. So this is the region 1, 1A, 1B, 1C comes under region 1. In this region 2, 2A, 2B, 2C, 2D. Like this, region 2, region 4 is 4A, 4B, 4C. Region 5 is 5A, 5B, 5C, 5D, 5E. And region 3 is 3A, 3B. Like that, it is going to be divided. So in that particular case, so first we have to find for the routing table for 1A. First this one only, for this particular case only, 1A. First only for one router we are going to find the table. First 1A we are going to find. Like that, we have to find for all other routers. How many routers are there total? For that routers we are going to find the routing table. So it is having the destination from 1A to where we have to go. From 1A to all other routers. How many routers are there in that particular cluster? We are going to send that particular packet, right? So we have to find the distance for each and every all other routers from that particular 1A. See how it is from 1A. It is going to be 1A is connected to 1B and 1C. That is the direct link. First we have to write that one. 1A and 1B. If I want to travel, 1A means 1A only. There is no nothing. There is no distance and there is no hops. That is empty. From 1A to 1A, there is no. From 1A to 1B. 1A to 1B, this is 1A to 1B. How many number of hops are there in between 1A to 1B? And that is only 1B. 1 only. And next 1A to 1C, if you want to travel, here how many number of hops is there? 1 only. So here is 1. That is also 1. From 1A to 2A, I have to travel. What are the routes are there for traveling 1A to 2A? 1A to 2A, 1A to 1B, 1A to 1B to 2A. And one more route also there, 1A to 1C, 1C to 1B, 1B to 2A. This is also another route. But what is the best route? Here the number of hops is how many are there? 1A, 1B, 2A. Only 2 are there. And if you go for this route, 1, 2, 3. 3 routers are there. 3 hops are there. What is the shortest one? 2 or 3? 2 is the best. So we have to write the 2. Means shortest only we have to mention. From 1A to 1B, what is the shortest one? 1A to 2A. What is the shortest one? 2. Through which route we have to go? 1B. That is the next hop. That we have to mention. And next one, 1A to 2B. 1A to 2B, how we are going to travel? 1A, 1B, 2A, 2B. Total 3 routers. So, 3 routers. And next hop is what? 1A. If you want to travel from 1A to 2B, so next hop is 1B only. That is only we mentioned because 1B and 1C are the direct links of direct neighbors of the 1A. That's why we are writing here the next hop is 1B or C only. We are in this total case we are writing B or C. Why we are writing B and C? Because only B and C are the direct neighbors of A. That's why we are writing only the next hop is B and C. So, next case is 2C. From 1A to 2C, if you want to travel 1, 2, 3, 4. 4 are there. But if you go for another route here, suppose this example, see, I am erasing this one. See, 1A to, I want to travel 1A to 2C, I have to travel. How I have to travel from 1A to 2C? See here, 1A to 2C, 1A. Here is the 2C. If you go for this route, 1, 2, 3. If you go for this route, 1, 2, 3, 4. So, which route is the best one? This one only, right? So, 1A to 1B, 2A, 2C. Total how many are there? 3 are there. We are selecting this one, right? That's why 1B we have to write. For 1A to 2D, we are going to travel. How we are going to travel? Again, we have to see here 1A to 2D, we are going to travel. 1A, 1, 2, 3, 4. Total 4 routers are there. If you go for this route also, 1, 2, 3, 4, 5. Total 5. The shortest is 4 only, right? That's why we are taking 1B only. Means through 1B we are going to travel. Like that 1A to 3A also. 1A to 3A, 1, 2, 3. 3 is there. 1A to 3A is 3. And next one, 1A to 3B, only 2 are there. Only 2. We are going to travel through what? 1C through we are going to travel. So that's why we are writing here 1C. Like that same way, 1A to 4A. 1A to 4A, see here, 1A to 4A, how we are going to 1, 2, 3. 3 hubs are there. That is 3. We are going to travel through C, that is C only. And 1A to 4B, how we are going to travel? 1, 2, 3, 4. 4 are there. That is 4, 1C through we are travel. And 1A to 4C. 4C also 1, 2, 3, 4. Total 4 is there. Here is 1C. Next 1A to 5A. See here 1A to 5A we are going to checking now. So in this case 1A to 5A. 1A to 5A, if you go for this route, so which one is the best route? We have to calculate 1, 2, 3, 4, 5, 6, 7. If you go for this particular route. Suppose 1A to 5A, if you go for another route. 1, 2, 3, 4. Only 4 only. So that's why which one is the best one? 4 only, right? That's why we are traveling through 1C. So 5B also, 5A is 4, 5B also 5, 1C. Next one is 1A to 5C we have to travel. See how we are going to travel 5C. If you go for this route, 1, 2, 3, 4, 4, 5. This is only 5. But we are coming in which route? 1B. That's why we are writing here 5. 1A to 5D is 6. Here is 6. 1A to 5E is 5. 1A to 5E. 1, 2, 3, 4, 5. Here is 5. We are coming in through the 1C. That's why we are writing here 1C. Like that we have to find the table for 1A. Means from 1A to all other routers in that particular cluster we are going to find the distance. See, this is okay. But if it is here only small range is there. Only number of routers are less. That's why it is okay. Suppose if 100 number of routers are there. That time how we are writing this particular table, that may be complex also. That's why we are writing, how we are writing the hierarchical table for this hierarchical routing algorithm is, for 1A we are writing, 1A direct links we are writing, 1A, 1B, 1C we are writing, because this is the region. That's why we are writing all as it is. And coming to 1D, we are writing only one record. Already we said, only we have to write one record for record 2. In this record 2, 2A, 2B, 23, 2C, 2D, till here are there, right? In this particular case, which one is the smallest distance? 1B. 2A, 1B is the 2. That condition you have to mention here. Means for going to that particular 2 region, you can, one node is, which one is the shortest distance? If we take that one, we can reach to all other nodes for that region 2. That's why we are writing the shortest distance of region 2. And for region 3, we are writing one record. So, region 3 is 3A, 3B. Which one is the shortest? 3A, 3B, 1C, 2. That is we are writing here. And 4A to 4C. Which one is the shortest here? 3, 4, 4. So, we are writing what? 1C and 3. 3 is the shortest. That's why we are writing 4A, C and 3. And next one, in this 5. In this 5 region. Which one is the shortest here? All are 4, 5, 5, 6, 6. Which one is 4 only shortest? That's why we are writing 5A, 1C and 4 we are writing. This is the table region 5 for, that is 4. Like this we have to write the hierarchical table for each and every router in that particular region. In that particular cluster also. This is for only one router I explained. Like this we have to consider for all other routers. This is about the hierarchical routing algorithm. And next algorithm is the broadcast routing algorithm. Broadcast routing algorithm mainly talking about the sending the packet to all the destinations. So here the source, this is the source. From this source to I am sending the packet, whatever packet I am having, I am sending the packet to all the destinations simultaneously. That is called as the broadcasting. Broadcasting, that is simultaneously we are sending the data. We are sending the packets to all other nodes. That is the broadcasting. These are the several methods we are going to using in the broadcast algorithm, broadcast routing algorithm. The first one is the multi-destination routing algorithm. This multi-destination routing algorithm, each packeting contains the either list of the destination. Each packet, whatever packet is there, that contains the list of all the destination. So you can send the data to the all the destination. When the packet arrives to that particular router, the router checks the destination and determine the set of output lines that will be needed. It is going to be needed. And the next one is the flooding. What is flooding here? Flooding already we discussed in static routing algorithm. Flooding is nothing but sending the data. Sending, it is not considering about anything, sending the data as it is. That is the flooding. When implemented with the sequence number per source, the flooding use the links efficiently with a decision rule at the routers. That is going to be relatively simple. So this flooding mainly talking about the point-to-point communication. It rates the seriously consideration for the broadcasting. Means whatever data is there, it will send as it is. Simultaneously, it is sending the data. That is called as flooding. These are all used for broadcast routing algorithm. These are all the several methods of broadcast routing algorithm. First one is multi-destination. You can send to multiple destinations at a time. That is also first method. And second one is the flooding. It's nothing but we can send the data simultaneously. That is flooding. And the next one is the reverse path forwarding. That is based on the sync tree. So here first, before going to that, first we will see spanning tree. What is spanning tree? Spanning tree is talking about subset of the network that includes the all other routers. Means spanning tree is nothing but it is a subset of network. It contains all other routers, but there is no loops. Main condition is there is no loops. That is sync trees are the spanning trees. Whatever sync trees we are saying that is the spanning trees. Sync tree, see in this picture. So A is talking about the network. Total network is like this. And B is talking about the sync tree. Sync tree is nothing but there is no loops in that particular network. There is no repetitions in that particular network. That is called as the sync tree. That is the reverse path forwarding. And the next case is see reverse path forwarding. We have to draw at the same time we have to draw the hierarchical manner also. Whatever routers are there, whatever nodes are there, you have to draw all the routers in the using this particular main node. You have to draw in the hierarchical manner. That is called as the reverse path forwarding. Based on the sync tree only, we are drawing reverse path forwarding. So all sync trees are nothing but the spanning trees. So each router knows which of its lines belongs to the spanning tree. It can copy an incoming broadcast packet onto all of the spanning tree line. Expect the one arrived on. Expect one word whenever it is going to arrive. Except that suppose here is A. It is arrived from B. Except this particular node will send the data to all other nodes. That is the broadcasting. So this method makes excellent use of the bandwidth and generating the absolute minimum number of packets necessary to do the job. Means whatever packet is there, it is sent to all other destinations based on the sync tree, based on reverse path forwarding, based on the flooding, at the same time multi-destination routing. These are the several methods for forwarding the data using the broadcast routing algorithm. And next is multicast routing algorithm. What is multicast routing algorithm? Multicast is nothing but one node to many nodes. We are transferring the data. That is also fixed node. So some applications send packets to the multiple receivers such as multiplayer game, live video of sports. Those are some examples for the multicast routing algorithm. So whatever data is going to be transmitted, mainly how it is going to be transmitted in multicast routing algorithm, send the packets to each receiver. Whatever receiver is there, you have to send the packets. Extensive broadcasting of the packets, that is restful. Extensive broadcasting is there. At the same time, sending the messages to well-defined groups that are going to be numerically large in size but small compared to the network as. Those are called as the multicasting. Means whatever message is going to be there, that is going to be sent to the different groups that are going to be large only but small compared to the network. Compared to the previous broadcasting, it is going to be small. Compared to the broadcasting, it is going to be small. That type is called as the multicasting. Here the routing algorithm used, whatever routing algorithm used for sending the small network, we can call it as the multicast routing. So, a single router in a network can be a part of two or more different groups. For two or more different groups also, one single router is going to be there. That is the multicast routing algorithm. So, this is example, this is a total subnet, total network. So, spanning tree is nothing but there is no loops, but it is leftmost router. And coming to multicast tree for the group 1, group 2, how it is going to be happen. See here, how it is going to be divided into different groups, right? So, it is going to be divided into two groups. So, the message is going to be divided into groups, that is called multicasting, right? So, and its algorithm is multicast algorithm. That is okay. But it is going to divide into groups, right? That is going to be two groups. To do this multicasting, we are going to divide it into two groups. First one is the group 1 and group 2. Some routers are attached to the hosts that are belong to one or both these groups indicated in the figure. This is the group 1 and group 2. This is indicating group 1. This is indicating group 2. This is the leftmost router of the spanning tree. So, how it is going to be happen? See here in this picture. A spanning tree for the leftmost router is showing in figure B. And when process sends to the multicast packet in that particular group, the first router examines its spanning tree and that is going to be prune it. That we have to prune is nothing but we have to cut it, removing all the lines that do not lead to the host that are member of that particular group. Means which one are going to be pasted in that particular group, we are going to remove all that particular. That is nothing but the group 1. So this is talking about the group 1. And next one, similarly figure D is talking about the group 2. Multicast packets are forwarded only along the appropriate spanning tree. Whatever packets are going to be there, that are going to travel within the appropriate spanning tree only, the packets are going to be travel. That is in group 2. This is about multicast routing algorithm. Means mainly compared to the broadcasting, this is the small network. Here also spanning tree is there, sync tree is there. Here leftmost or rightmost routing is there. Suppose whatever waste nodes are there, that is going to be removed here. That is the pruning process is there in multicast routing algorithm. But in broadcast, there is no pruning. That is the difference. And coming to the summary, today's session we discussed what is hierarchical routing algorithm, and next we discussed broadcast routing algorithm, and next we discussed multicast routing algorithm in routing algorithms. These are the all routing algorithms. Finally, we discussed total routing algorithms. What are the routing algorithms are there? It is going to be divided into static and dynamic. Static algorithm, dynamic algorithm. Static is having the shortest path, Dijkstra's shortest path algorithm, and next flooding, and next flow based. These are considered as static. And coming to the dynamic, distance vector routing algorithm, link state routing algorithm. These are the dynamic algorithms. And apart from this also, the static and dynamic, we are going to discuss we discussed hierarchical routing, broadcast routing and multicast routing. These also comes under the routing algorithms in network layer. So we discussed all the routing algorithms in network layer. So thank you.